Good morning. Welcome to the webinar on SPE Technical Directors Talk. Today, our speakers are the Technical Directors of Reservoir and Production and Facilities. I have from Green Resources, Bob Pearson, who is the Production and Facilities Technical Director for the SPE. And I also have Dr. Rodolfo Camacho, who is the Reservoir Technical Director with the SPE, and he's a professor at UNAM in Mexico. So today, we are going to talk about some interesting topics for all of us these days, and I'm sure you're going to enjoy their wisdom and their perspectives on these problems. I would like to start with my first question to Rodolfo. Rodolfo, we have been talking about the integration of various disciplines involved in the production of hydrocarbons, EOR, and now also carbon capture and sequestration. It's somewhat disappointed that after 2 or 3 more decades, we are still struggling with these efforts to integrate all our disciplines involved in the production of oil and gas and EOR and some other activities we are in. So one idea to promote the integration of geology, reservoir, and production for project assessment is to develop and use unified simulators. Can you explain what would be the benefits of a unified simulator for project assessment and optimization, please?
Yes, sure, good morning. The integration of geoscience, reservoir, and production specialists is possible using integrated simulators that are now available in-house and commercially after 2-3 decades of development. These simulators include geoscience, including geology, geomechanics, fluid flow in the reservoir, wellbore completions, and facilities modeling. The unified full field modeling can furnish benefits both operationally and economically. It enables the integration of multiple disciplines, a better data management, data consistency by multiple users, the improvement of production forecasts, and better project management decisions. With the use of these simulators, it is possible to make an appropriate field management because we can address well locations and trajectories, completion designs, facility management to increase production, a range of incremental production opportunities can be generated and ranked for implementation, including artificial lift methods, facilities debottlenecking, a review of downhole of existing downhole wells to identify behind pipe opportunities to extend the life of existing wells, and screening EOR and CCUS possibilities. With a well-grounded production forecast, honoring all the restrictions of the whole field, we can calculate the total cost of production, starting from the reservoir and advancing to the whole production system. Once we do that, we can evaluate different production scenarios, and an asset optimization can be accomplished with an improvement on the economics of the project. For unconventional reservoirs, we can identify key uncertainties that must be addressed to ensure that new wells continue to meet the expectations. And if they don't are within the range of unexpected rates, we can probably answer why this may be the case. An important advantage of these simulators is that non-uniqueness can be extended to the domains of production and facilities.
That's gonna be quite an interesting tool for most of us to use in the discipline. But of course, there will be many challenges to the development of this type of simulator. So I would like to ask Bob, Bob, what do you think will be the major challenges for the development of such a simulator, especially considering the fact that the users will still have some individual specialties? So what would it take to use such an integrated simulator from the perspective of the users?
Yeah, thanks, Erdal. Great question. I've grown up with the development of these tools. So the digital oil field has been around for about, I don't know, 30, 40 years. And we've been working with ever more sophisticated integrated tools. And I used to tease the people at Mobil that you have to be careful because Pegasus, the flying horse, was not a great racehorse and it wasn't a great bird, and watch out if it went wrong. So the issues, one is a project management issue. You have a problem to address, and it's very easy to get drawn into trying to make the model work as opposed to answering the development question about what should we do next. So sometimes the real issue is sort of obvious. It's bottlenecked in the gathering system, and therefore we need a completely new workflow. You start off working on the gathering system and then work back to the reservoir. Whereas with a screening study for an opportunity screening, you'd start off with the reservoir piece and come back to work on the wells and then finally onto the facilities. So that they're absolutely fantastic tools. You do have to make sure that each of the components are meeting the functionality. With some of them, I don't know where the gathering system model comes from and how robust it is. So it's a bit of scary that you're dealing with a black box. So that's one of the issues. But they are advancing very quickly. The question is whether you use a adjustable wrench to solve a problem, or do you want to use a precise tool to look at the details of one specific issue. And so that becomes a project management challenge, I think. But they are fabulous, absolutely fabulous tools, particularly at the screening level.
That's very nice. Again, in terms of hearing the background, and that this tool is not going to start from scratch. It's going to be more like a development of what we already have. But at the same time, we are talking about the teamwork, which will require the use of this simulation. We talked about the individuals feeling comfortable with the tool, getting used to the existence of this tool and incorporating it in their work. But at the same time, considering the integration experience we have had so far in our industry, how would you envision this teamwork of specialists would happen in our imperfect world. I would like to start with you, Bob, if you can continue. And I would like to also ask you to limit your answers to about 1 minute or so.
Yeah, well, I worked in a consultancy where we built a lot of these models for people. And again, it is a matter of having the right project manager and making sure that people don't stray outside of their expertise. The reservoir engineers got to work on the reservoir model, and the production engineers got to work on the lift and gathering system model. And I particularly like the plug and play pieces because, if I then want to add a process simulator at the end, I'd like to plug it in at the end. So I think the plug and play with tools that we're already familiar with is a great way of doing this rather than a total black box that's fully integrated. But I think it's just a management issue. With a good team, it's easy to do. The danger is that management think that a very highly computer literate person with a super tool can replace some specialists. So I don't think you can.
Okay, thank you. Rodolfo, what do you think?
Well, what it is important to remember is that the reservoir and production engineers are in control of the simulations and not controlled by them. The engineers finally are the decision makers. This approach requires interaction of an engagement of different teams working together, and the people element is a key, is crucial for the use of these tools. It requires us for any organizational change and adaptation like this, that the top manager needs to be convinced that the use of these simulators will make the management decisions easier. That is an important factor.
Thank you, Rodolfo, and thank you, Bob. I think this is going to be an interesting improvement in our industry and in our teamwork, definitely. So I would like to move to our next discussion topic, which is probably going to be much more timely based on the discussions going on. First of all, I would like to direct this question to Rodolfo. With the public attention and the government support on net zero initiatives these days, there is a lot of interest in injecting CO2 and other greenhouse gases into hydrocarbon reservoirs for EOR or CCS projects. As a reservoir specialist, how do you see these opportunities?
Well, the oil industry has great experience in the use of CO2 from natural sources for EOR, and that provides a good knowledge for CO2 storage. With about 2/3 of original oil in place in mature conventional oil reservoirs remaining after primary and secondary recovery efforts, the use of anthropomorphic CO2 for EOR is a good candidate. The on-the-ground sequestration can also be accomplished by injecting CO2 in depleted reservoirs and in deep saline aquifers. Many operating companies are deploying CCUS projects for both centralized emissions and for EOR. According to Mark Subak of the Center of Carbon Storage at Stanford University, the current CCS projects imply around 40 megatons of CO2 per year. 8 years In about 8 years, the amount of CO2 capture and store should be in the order of 1 gigaton per year, and in 15 years, it is expected that this amount should be in the order of 3.4 gigatons, which is close to the current global oil production of 30 billion barrels per year to achieve the 2 degrees C scenario. CCUS in a closed volume system, like some saline aquifers, cannot be achieved because as pore pressure increases with time, the injection pressure will have to rise to maintain injectivity, which can result in some geomechanical problems, such as the induced seismicity, fall and fracture activation, surface heat, and wellbore integrity issues. Thus, according to Gary Telesky, distinguished lecture webinar, he said that the storability factor on non-depressed closed systems is less than 1% of the pore volume due to injectivity problems. These effects are minimized for EOR, where the goal is to balance the injection and production to keep the pore pressure below the fracture initiation pressure. However, CO2 for EOR alone will be insufficient to meet the emission reduction target. Huge injection of CO2 is required in depleted offshore and onshore reservoirs to reduce carbon emissions, where there is geologic knowledge, storage capacity, and much of the infrastructure in place.
So that's definitely a possibility for us to use. And CCS is one of the considerations to get rid of the greenhouse gases. There is no doubt about it. It may not be sufficient, but it's one of the tools. Now, I would like to ask Bob, probably a little difficult question, but forgive me, Bob. We have known each other for some time, and I know you can handle this. So, general public easily gets excited about any potential solution to climate change problems. But as technical experts, we cannot get just excited. We have to keep a level head and figure out all of the facets of the proposed solutions. So what do you think the issues related to CCS might be right now and that there will be in the future?
Yeah, another great question, Erdal. The general public are probably not as excited as I am. I think it's a fantastic new opportunity. I'd love to be a YP working on this, but as you say, we've got to balance the risk quantification of the risks. Where are the risks? The question of the devil that we know versus the devil that we don't know, and so it's tempting to think that that we will be able to make re-injection into depleted pools easy, but if it's pressure depleted, we've got a problem with downhole hydrates. We've obviously got a problem with well integrity. That's manageable. It just means that we've got to put into the costs of the system a continual round of workover operations to make sure that we're not emitting anything more than the average cow is emitting. So it's all manageable things, but there's a lot of work that's got to be done. If you look at aquifers, the question is, well, what is the continuity of the system, and are we going to have to drill additional wells to draw water off, or as Rodolfo says, are we going to be fighting injectivity and have to drill additional injectors? So it's a game of running scenario after scenario in stage gate 2, where we're looking at the alternates, and in stage gate 3, where we're trying to optimize the system. And that's where these integrated tools come in, because there's a huge amount of engineering here. It's going to keep us all very busy for the next couple of decades.
Well, excellent. I think you mentioned something really interesting here. You put some kind of measure in your talk. It is the average cow's emission. So I will definitely be using this in the future. But the issue here is to find a way for safe, economic, and sustainable geologic sequestration of greenhouse gases. That's definitely a challenge in front of us. So, Rodolfo, do you feel that we have enough knowledge right now to do this, or what type of activities do you envision to have a reliable geologic storage option going forward?
Yes, Serdar. Well, to reduce uncertainties related to safe storage and proper injectability, some research topics should be undertaken to understand how CO2 behaves under different underground environments. For example, the hysteretic behavior that may present relative permeabilities and capillary pressure curves for different type of rocks is one subject that we need to look into. These curves have an influence in the CO2 trapping mechanism, and especially in saline aquifers. The concentrations of particulate suspensions are sometimes present in industrial CO2 streams, and the injection of such fluid mixtures into the reservoir may have some impact in the petrophysical properties, especially in the region close to the injection wells. The solubility of CO2 and geochemical reactions that could cause permeability changes in some saline aquifers in carbonate rocks, the injectability problems and reactivation of existing faults during injection process in saline aquifers, the effects of depletion on the state of stress in the reservoirs and on petrophysical properties, the evolution of the in situ stress due to CO2 injection and corresponding geomechanical effects, the cap rock integrity and geomechanical limits on the injection pressure, possible initiation of fractures and reactivation of existing faults, together with the generation of earthquakes, the possible generation of earthquakes, leakage of wellbores that requires the development of new tools to evaluate well integrity and risk assessment, and new materials, tools, and techniques for repairing these issues. Those are some of the research and development and studies that we need to do, integrating all the geological reservoir characterization and geomechanics are required to identify reliable underground storage of CO2 and appropriate injectivity conditions.
Thank you, Rodolfo. Bob, what do you think about the R&D activities we will need?
Yeah, we clearly are going to need ongoing R&D, but at the same time, we need to get after it. We've got a number of successful pilots running, and pilot testing is going to be really important in learning how to do this. So we've got two big projects here in Canada. There's projects in Europe, projects in the US. I think one of the key areas of R&D is small scale capture of the CO2. So how do we capture the CO2 from the recompression compressors, for example, in the recycle in an EOR project? The green lobby is all over us about whether we're really effectively sequestering when we're doing EOR. So we need to solve that. There's a number of good research initiatives going underway. I would like to make a plug for the storage reservoir management system. The guidelines are just about to be published. A lot of great discussion within the CCUS technical section of the SPE. I tuned in the other day and they were talking about how we are going to have to develop new ISO standards for port facilities handling CO2, for example. If you think of Northern Lights, they're going to be loading the CO2 onto the tankers in a conventional port. So what have we got to do around safety of all of that? So I think it's phenomenally exciting. There's a lot of good R&D that needs to be done, particularly things in the D end of that. What can we get to the market within the next 5 years?
Very nice. I would like to follow this up with a question from the audience. This question is from Hector Partidas Reyes. He was just wondering about the life, at what point in the life cycle of the well or reservoir we should start this EOR or the CCS activity. Either one of you or both of you. Go ahead, Rodolfo.
Well, the start of EOR or CCUS, especially, let's separate that EOR and CCUS. But for EOR, it depends on the company, the price of the oil. Several factors are involved, but it is important to remember that there is during the life of the reservoir, there is an optimum period where we can start an EOR process. CCUS is similar, but now we have the complications to make economically attractive to capture the industrial CO2 and then use it for EOR. Then it is in my way, there is not a definite answer to this question. It's a good question, but there is not, depends on the case that we have.
Many factors. What do you think?
I think you have to start studying it on day one. You do have to have some primary production period in order to do some material balance studies, but thereafter you should be seeing if economically you can drive a secondary recovery process and then keep on extending the plateau by progressively moving from secondary to tertiary. But why not use CO2 for a gas drive, for example, or use a simultaneous CO2 and water drive? No, we don't know, and we need to be studying it right from day one. And I suspect we should not be waiting as long as we've been waiting. Repressuring takes too long.
I can see that Rodolfo is taking a little bit more cautious approach, whereas Bob is actually more excited about this, and he wants to see the implementation as quickly as possible. But definitely there are a lot of questions around greenhouse gas storage in oil reservoirs. So this discussion will be continuing. But for today, we came to the end of our time, and I would like to thank two of our speakers, Rodolfo and Bob. Thank you for your excellent answers, and I hope to see you in another SPE webinar. For today, that's it. Thank you.
Thank you, Erdal.
Thank you, Erdal. And thank you.